Okay, so welcome to the deep dive. Today we're going to try to get to the bottom of, this question of can we really rely on AI when it comes to medical images?
Right.
We've
Yep.
got all these amazing advances in deep learning, and it seems like AI is getting really good at looking at an X-ray or a scan and saying, this looks like this or that. But for doctors to really feel comfortable using this in the clinic, they need to know how sure the AI is about its diagnosis.
Yeah, absolutely. And that's exactly what makes this research paper so interesting. Tackles this problem head on. How can we make sure that these deep learning models don't just give us an answer, but also tell us how much they believe in that answer?
Right, like how confident they are. So we've got this new method called actionable uncertainty quantification optimization, or AUQantO.
AUQantO. Yeah.
And basically it's all about making deep learning for medical image classification much more reliable by dealing with this whole issue of uncertainty. So our mission today is to really break down how AUQantO works and why it has the potential to be so important for healthcare.
Yeah. I think a good way to think about it is, it's not just about getting a faster diagnosis, but a clearer one where we really understand the limitations of the AI. And that's really important for doctors to feel confident, integrating these systems into their practice and ultimately improving patient care.
Okay, so let's dive in. We all know deep learning, particularly convolutional neural networks, these CNNs, have been incredibly successful in medical image classification. They're doing things like, distinguishing between different types of images, like telling a benign tumor from a malignant one.
Right, and doing it really well in a lot of cases,
Yeah.
which is amazing when you think about how much training it takes for a human to do that reliably.
Yeah, it's really remarkable. And what's really exciting is the potential to do this at scale and really quickly. Imagine being able to scan through a huge backlog of images with AI, highlighting the ones that might be problematic so doctors can focus on those first.
Exactly. That kind of triage could be a game changer,
Hmm.
freeing up time and potentially leading to earlier diagnoses.
But here's the thing. Even the best doctors sometimes aren't sure. They might need a second opinion or more tests. And we need our AI systems to do the same, to recognize when they might be wrong.
That's where uncertainty quantification comes in. It's about giving us that confidence score. So instead of just saying, this is a tumor, the AI also tells us how certain it is.
So it's like a measure of how much it trusts its own judgment. And
Exactly.
why is that so important in the medical context?
Well, for one thing, it can help flag those images that might be tricky. Maybe they're blurry or there's some artifact that makes it hard to interpret, or maybe the image itself has some unusual characteristics. These are the cases where the AI's prediction might not be so reliable.
So instead of just giving a black and white answer, it's more like the AI is saying, well, based on what I've learned, this looks like X, but
Hmm.
there are a few things that are making me hesitate.
Right, and that's incredibly valuable information for the doctor. It allows them to make a more informed decision. And it moves us towards this idea of more transparent and explainable AI, which is really critical for building trust.
Okay, so that brings us to AUQuanto. The researchers are presenting this as a new way to boost the performance of deep learning for medical image classification. And one of the things that's really interesting is that it's not specific to any particular AI model or even to a certain type of medical image.
Right, it's meant to be very general and adaptable,
Hmm.
which makes it potentially very useful in a lot of different settings.
So how does it actually work? What's the secret sauce?
Well, you can think of AUQuantO as having two main parts. First, it optimizes how we measure uncertainty. We already have some techniques for that, but AUQuantO tries to make them better. And then second, it introduces this idea of the AI abstaining, basically saying, I'm not confident enough to make a call on this one.
So it's like a safety net.
Exactly.
Now, the paper mentions two specific techniques that AUQuanto uses to figure out how uncertain the AI is. Can you walk us through those?
Sure. The first one is based on something called Shannon entropy. Now, I know that sounds technical, but the idea is actually pretty straightforward. When the AI looks at an image, it assigns probabilities to different possible classifications. So it might say, there's a 40% chance of this, a 30% chance of that, and a 30% chance of something else. If those probabilities are kind of spread out evenly, like in that example, that means the AI is more confused. It's less certain about the answer.
So its guesses are all over the place. It doesn't have a strong conviction.
Right, and that's what the entropy score captures. It measures this ambiguity. But if, on the other hand, the AI is very confident, like it assigns a 95% probability to one classification,
Yeah.
and very low probabilities to the others, then the entropy is going to be low, indicating a higher level of certainty.
Okay, so that's a first technique, Shannon entropy. What about the second one?
The second one is called Monte Carlo, or MC dropout, and this builds on a method called dropout, which is often used during the training of deep learning models. Now, what dropout does is it randomly switches off some of the connections between the artificial neurons in the network during
Makes sense.
training.
It's like intentionally introducing a little bit of noise or randomness.
Yeah, that's a good way to think about it. And this helps prevent the AI from becoming too reliant on very specific patterns in the training data. It helps it generalize better. But what AUQantO does is it keeps this dropout process active, not just during training, but also when the AI is actually analyzing a new image. So it runs the same image through the network multiple times. And each time it randomly turns off a different set of connections.
So it's like getting multiple slightly different opinions from the AI on the same image.
That's a good analogy. And then by looking at this collection of predictions, you can calculate an average prediction. But more importantly, for our discussion of uncertainty, we can also see how much those predictions vary.
So if they're all very close together, that suggests the AI is pretty consistent, indicating lower uncertainty. But if the predictions are all over the map, that suggests the AI is less stable in its assessment.
And therefore more uncertain.
Right. And the researchers really emphasize that AUQantO is what they call data-agnostic and a post-prediction component. Can you explain what that means and why it's important?
Yeah, so data agnostic means it doesn't matter what kind of medical image you're using. It could be an X-ray, an MRI, a CT scan. AUQantO can work with any of them.
So it's not tied to a specific type of data. And what about post-prediction component?
That means you don't have to go back and retrain your entire deep learning model to use AUQantO. It basically sits on top of your existing model and analyzes the predictions it's already making. So you can think of it as an add-on. That enhances the reliability of your AI system without requiring you to start from scratch.
That sounds incredibly useful, especially in a hospital setting where they might already have AI systems in place.
Exactly. It makes it much faster and more cost-effective to implement.
Now, you mentioned this idea of a threshold, which the paper represents with the Greek letter lambda. How does that fit into all of this?
So the threshold is this critical value that we compare against the uncertainty score that the AI calculates for an image. Remember, we talked about how the AI can measure its own uncertainty using things like entropy or MC dropout. So if the AI's uncertainty score is above this threshold, then AUQantO says, hold on a second, this one's too uncertain. Let's flag it for a human expert to review.
So it's like the AI is raising its hand and asking for help.
Precisely. And that's where the actionable part of the name comes from. These flagged images are the ones that need further attention.
But how do you choose the right threshold? It seems like if you set it too high, the AI might still make some wrong predictions because it's overconfident. And if you set it too low, the AI might abstain too often. And then you're just overloading the doctors with images to review.
That's exactly the challenge, finding that sweet spot. And that's where the optimization part of AUQantO comes in.
So they're basically trying to find the best possible threshold.
Right. They're using different computational methods to automatically figure out what that optimal threshold value should be.
And they looked at both single objective and multi-objective optimization. Can you give us a simple explanation of what those are?
Sure. So single objective optimization is like focusing on one specific goal. Like, let's say you want to maximize the accuracy of the images that the AI does classify. So the algorithms they use for this, things like Bayesian optimization, co-belay, and dual annealing, they're basically sophisticated ways of trying different threshold values to find the one that gives you the best possible accuracy.
So they're searching for that point where the AI is most likely to be right.
Exactly. When it makes a prediction.
And what about multi-objective optimization? What's the advantage there?
Well, multi-objective optimization lets you consider multiple goals at the same time, even if those goals might be in conflict with each other.
So in this case, you might want to maximize the confidence of the included images, but also minimize the uncertainty of the excluded images.
Right. And the nice thing about multi-objective optimization is that it gives you a set of different solutions that represent different trade-offs. So one solution might give you slightly higher accuracy on the included images, but it might also exclude a few more images overall, whereas another solution might include slightly more images, but with a bit lower overall accuracy.
So it gives the medical team more flexibility to choose a threshold that aligns with their specific priorities.
Precisely. They can choose the solution that best fits the situation.
Like if it's a really critical diagnosis, they might want to be extra cautious and choose a threshold that leads to more abstentions, even if it means more manual review. Now, to really see how well AUQantO performs, the researchers tested it on a variety of real medical image datasets, and they used different deep learning architectures, which is important to make sure it's not just working by chance with one specific setup.
Exactly. It needs to be robust and generalizable. So they used 4 different architectures.
Yeah.
Two-stage, CN, DSF, CNN, hybrid, LSTM, and EMSnet.
And they tested it on 4 different collections of medical images.
Right.
So let's start with the breast cancer histology dataset, the BACH dataset. What were some of the key findings there?
Well, one of the most important things they found was that AUQantO consistently led to an improvement in average accuracy across all 4 architectures.
So no matter which deep learning model they used, adding AUQantO made it perform better.
Right. And interestingly, the NSGA multi-objective optimization method often resulted in the highest accuracy for several of those models on this particular data set. And they also found that the DSF-CNN architecture seemed to work particularly well in combination with AUQantO on this BACH data.
But what's really interesting is that they didn't just look at the overall accuracy, they also looked at the accuracy of the included images versus the
Right.
excluded images.
Exactly. So, remember, the included images are the ones that AUQantO felt confident about, and the excluded images are the ones that flagged as too uncertain. And they found that there was often a big difference in accuracy between these 2 groups.
So the AI was actually doing a good job of identifying the images that were more likely to be misclassified.
Right. The ones with that higher uncertainty.
And that's exactly what you want. You want it to catch those tricky cases and send them to a human for review.
Precisely.
And did they see similar results with the skin cancer dataset?
Yes, they did. Again, applying AUQantO improved the accuracy across the different architectures, and the NSGA2 method often performed the best. And the DSF-CNN also showed very strong results on this dataset.
So it seems like there's a pattern emerging here. AUQantO is consistently helping.
Yeah, it's looking very promising. And it's not just limited to one type of medical image or one specific AI model.
Now, the paper also talks about this idea of abstain percentage, which is basically the proportion of images that AUQantO decides not to classify. Did that vary much depending on the setup?
Yes, it did, actually. It varied quite a bit depending on which deep learning model they were using, which uncertainty technique they were using, entropy or MC dropout, and which optimization method they were using to determine the threshold.
So it seems like that optimization process is really crucial to finding the right balance.
Absolutely.
Yeah.
You want to exclude enough of those uncertain cases to improve the overall accuracy. But you don't want the AI to abstain so often that it becomes impractical. You still want it to be doing its job.
And to make sure that these weren't just flukes, they also did some statistical significance testing, right?
Yeah, they use some standard statistical tests,
Yeah.
like the paired t-test and the Wilcoxon signed rank test, to make sure that the improvements they were seeing weren't just random chance. And the results consistently showed that the improvements achieved by AUQantO were statistically significant.
So they're pretty confident that it's actually making a real difference.
Right. It's not just a fluke.
Now, of course, it's important to compare AUQantO to other existing methods for handling uncertainty in medical AI. So they did that right.
Yeah, they included some comparisons in the paper with other methods that have been proposed in the research literature.
And how did it stack up? Did AUQantO hold its own?
It actually performed very well in both the breast cancer and the skin cancer evaluations. AUQantO showed superior performance compared to the other methods.
So it seems like this combination of optimizing uncertainty quantification and having this explicit mechanism for abstention.
Is a really effective strategy.
And just to show how versatile it is, they also applied AUQantO with the DSF-CNN to 2 more data sets, right? One for brain tumor MRI images and one for chest CT scans.
That's right. They wanted to see if it could generalize to other types of medical imaging tasks.
And what did they find?
Well, they found that AUQantO, again, led to improvements in performance on both of those data sets, which suggests that it has the potential to be widely applicable across a variety of medical imaging applications.
So for our listeners who might not be deep learning experts, what's the big takeaway here? Why should they care about AUQantO?
I think the main message is that AUQantO provides a practical way to make medical AI more reliable. And it does this without requiring hospitals to completely retrain their existing AI models, which is a huge advantage. It also really highlights the importance of not just getting the right answer, but knowing how confident the AI is in that answer, especially in a field as critical as healthcare.
And this ability for the AI to say, hey, I'm not sure about this one, maybe a human should take a look, seems really important for building trust in these systems.
Absolutely. It allows doctors to focus their expertise where it's most needed.
So to wrap up our deep dive today, we've explored how AUQantO offers a new way to optimize the use of uncertainty measures. to boost the accuracy and the reliability of deep learning in medical image classification.
By intelligently setting a threshold for when the AI should abstain, it really have the potential to make AI a more dependable and effective partner for medical experts.
But here's a question for you to think about. We've been talking about medical imaging, but what about other areas where AI is being used to make important decisions? Things like finance or self-driving cars or even climate modeling. How could we apply these ideas about uncertainty quantification to make those AI systems more trustworthy as well?
That's a great question, and it's one that we all need to be thinking about as AI becomes more and more integrated into our lives.
So if you're interested in learning more, I encourage you to check out the research paper on AUQantO and maybe explore some of the broader concepts around uncertainty quantification in deep learning. Thanks for joining us for this deep dive. Until next time.